We're going to make a gyratory pill to be tested for volumetrics. And I'm going to begin doing that right now and show you exactly how it's done. Any way you want to put it in your mold is fine, but the easiest way to do it is the best way to do it, whatever works for you. A lot of times people use a scale pan. You can put it in a small bucket, whatever you want to do. We've, in the past, used a small bucket, and I think that's what I'll do today. I can put this bucket here, tear it out, this pan of material that would have come from a truck. Have a flat bottom scoop. And this material is a 9.5 millimeter A mix. The compaction temperature on it is 285 to 290. So, and I know from as many times as I've done this in the past what this mix is and how big a sample I need. And to do this, I need about 5,150 grams. And you go all the way to the bottom, get yourself a scoop, put it in there. All right. So now my sample size is about perfect. And normally speaking, I would put this back in the oven, put a thermometer in it, and when it reaches compaction temperature, I would compact it. Bring out a heated mold. A funnel. To these papers. One of the papers goes on the bottom. Your funnel. My temperature is 285. And when you pour this in, you pour it all at one time. You don't want to trickle it. You want to just make sure, dump it as a mass. Level the top out a little. Put the other paper on top and carry it to the compactor to compact the specimen. Slide this in all the way back, tighten it down. You put on your top plate. Tighten this. This is a 9.5A, set at 50 gyrations, 1.16 internal angle, and 600 kilopascals. And we'll just hit start. this is gyrating, and at the end of its cycle, it needs to be between 110 and 120 millimeters tall. You're looking for 115 millimeters. Okay, now it's done 50 gyrations. It's 115.7 millimeters tall, which is well within the range. So after it does that, you loosen this, take your top plate off, and you press the up button. You have to hold the up button for safety reasons. If you turn this loose, it quits extracting. You don't want to put your fingers or anything near anything over there because it'll do you some serious damage. Take the top paper off, throw it in the trash. And you can remove the pill. And set it down. Take off the paper. And you wait for that to become room temperature. Then you can weigh it in air, weigh it in water, and do all your volumetric testing. The next thing we're going to do is we're going to run a GMM, which is maximum mixed gravity, also called Rice gravity. We're going to quarter that down, much like we did the sample for the asphalt content furnace. Now I'm going to grab the sample and bring it over. And again, this is an SM 9.5 sample, and we're going to round it up just like we did before. We're going to turn it over. Quarter it down. Look at it, make sure it's homogeneous. We're going to take opposite quarters, and we're looking for a minimum sample size on this of 1,500 grams. Okay, I've got 1,599 grams, 1,600 grams, which is that's plenty. So I'm going to spread that out right here in front of the fan to cool. Spread it out, and while it's cooling, we'll break it up and make sure that there are no conglomerates in there bigger than a 1/4 inch. And that'll take, 10, 15 minutes, whatever it is, get down to room temperature. After this is set, we made sure there are no chunks in it, no conglomerates. We've broken everything up less than a 1/4 inch. We're ready to weigh this sample and run our rice test. So the first thing we're going to do, we're going to get a tare weight on this container. And I'm going to record that right here. right, and then I'm going to just kind of brush this sample into my scale pan. Put it in here. Kind of make sure it's leveled out. And I'm going to get the weight of the sample and the bucket. Record that. And now I'm going to bring it over to the vibrating table, cover it with water, and suck a vacuum on it for 15 minutes. And this has got a clamp on it, you clamp it down. Now this has got to be covered with water. So I'll get my water out of the water bath there, which is approximately 77 degrees for this test. You cover it up at least an inch or so above the sample. Make sure that's covered. And sometimes you'll get a little piece of something floating in there, and if you put just a drop of wetting agent in there, Dawn dish detergent, whatever, and I do mean just a drop, those things will sink. But it's plenty good. So, okay, then I'll take the top, wet this O-ring, make sure there's no trash in there, set this on here, close this, turn on the vacuum pump, and this thing you have to kind of press it down, and you can hear it when it okay, and you turn on the manometer, which is here, and this has got to pull down to 27 and a half plus or minus 2.5 is what we're looking for. So I've got that going. Needs to be between 25 and 30. All right, once it gets in the range there, we'll start the vibratory table, and we're going to set this at 15 minutes, and this has got to go 15 minutes plus or minus 2. This has got to be 27.5 plus or minus 2.5, so it's pulling down a little bit too low. Open it up a little. We're at 28 and we're good there. That's fine. All right, and once this is finished, it's done its 15 minutes. Cut this machine off and release the pressure extremely slowly. And it says 60 millimeters of mercury per second. And that's kind of hard to see, and I think the right answer is just do this very slowly. You don't want that big rush of air to go back into your sample. Or you don't want to draw water into your vacuum pump. Okay, that's back about where we started, so this ought to just lift right off now. And what we're going to do, we're going to take this over to this water bath, which is 77 degrees. Zero our scale. This is 77 degrees. Gently put it in there, cover it with water, set it on this. This has to be, make sure that the string isn't touching anything. It's a thin string that's totally underwater. There's an overflow on my tank, and this is going to go for 10 minutes, plus or minus 1. Okay, so after that's been in there for 10 minutes, we want to record the weight of that sample and container in water, which is 23.95.8. All right. So now I'll take this out and dispose of the sample. Okay, the only other number that I need now to complete this test is to get the weight of this in water. And we'll just let that hang there until it stabilizes. Look at that. And it's stabilized at 1405.1. Okay, so now in order to do the calculation, I need to get the weight of the sample that we had in the bucket in air, which is 28.4 minus 2235.9. And which is 1592.5. Now I need the weight of the sample, just a sample in water. So I'm going to subtract 2395.8 minus the bucket weight, which is 14051, which is 990.7. Then I'll subtract 1592.5 minus 990.7, which is 6018. 1592.5 divided by 601.8 equals. That's 2.646. And that is my GMM. That is the answer we were looking for, which means that this material is 2.646 times heavier than the same amount of water. Now we can use the numbers that we have for this and calculate the air voids in this specimen. All right, so what we're going to do with this is we're going to get the bulk specific gravity of this pill, and from that bulk specific gravity of this pill and the rice we just ran, we'll calculate the air voids. So the way you get the bulk is you get the dry weight of this sample in air after it's cooled back down to room temperature. And I'll record that. 51, 41, 9. 51, 41, 9. So now we're going to put this in a 77-degree water bath. And that's supposed to be plus or minus 1.8 for this test. For the rice, it's 2, but it's all good. 77 degrees. Put that down, and again, you've got small string where it goes through the water, the cradle totally underwater, not touching anything, not touching the bottom, everything's suspended all the way around. And this goes for 4 minutes, plus or minus 1 minute. And while that's doing that, I'm going to have to get a SSD weight. So you dampen a towel. You don't want to use a dry towel for this. A dry towel pulls the water out of the voids, and you're going to get an incorrect number. So you want this moist, and the weight we're going to get, we're going to call it saturated surface damp instead of saturated surface dry. This will be a saturated surface damp condition. Okay, now this has been in there for 4 minutes. And it weighs 3135.2. So I'll record that weight. Now I'm going to take it out of here. Place it on the damp towel. We're going to roll it down, tap it on the bottom, tap it on the top, make sure we got a 0, set it back, and that weighs 5145.7. And now we're ready to do the calculation on that. That's all we need. Okay, so what we're going to do is we're going to subtract the weight in water from the weight SSD. The weight SSD was 5145.7 minus 3135.2, which was the weight in water. So 5145.7 minus 3335.2, which is 1810.5. Let me do that again to make sure that I'm right. It's 31, 51, 5145.7 minus 2010.5. Difference of 3135.2. And you divide that back into the original weight, which was 5141.9, divided by 2010.5. Gives you a 2.558. And if you divide that 2.558, you divide that by your Rice number, which gives you 0.967. Subtract that from 1. Gives you 96.4 density and 3.6 air voids. And that's all there is to it.